Hello guys, and welcome to this video about Janus-Pro entitled Unified Multimodal Understanding and Generation with Data and Model Scaling. So this paper came out today, and I'm going to give you a very high-level overview, even though the paper itself is not very technical, of what they propose. So you can already see some images, and it's quite remarkable, especially in this one, to see the difference between Janus, which was the original model, and Janus-Pro 7 billion, which is the largest parameter model in this new paper. So the first thing they state is that current tasks on diffusion, so in creating images, use the same encoder and use the same encoder for image generation and image understanding. And they decouple this in their paper in order to prevent one encoder from doing two things suboptimally, in their words. This is how they say it. So if you scroll down here, you can see what the architecture is. It's a decoder-only transformer where there is a encoder for understanding tasks and a encoder for generation tasks, and each one has a separate head as well for decoding. So that's what I just said here. In terms of the architecture, there is a sig-lip 2D to 1D encoder for understanding, and this is right here. And then it's concatenated with whatever text in order to produce the output. And for the image generation, they use VQ tokenizer with rectified flow. So there's also an image input here, and there's no explanation in this paper, but if I looked at their previous paper, and it looks like they use rectified flow in order to create images, which is to say they start with a very noisy image and then feed it through the network in order to decode it. One thing to note is that both understanding and generation have an adapter to map to the large language model's input space. That's to say, the encoder itself does not map to the text input space of the LLM. After the encoder, there's an adapter as well. And once the adapter gives the proper formatted output, it's then concatenated with the text tokenizer. So you can see here, features are concatenated into a single multimodal feature sequence, which just means that text and image become one. And like I said, there's two prediction heads. So the built-in prediction head is this one here used for text iteration and understanding. And then they randomly initialize one, which is trained with supervised fine-tuning for image generation. Okay. Now, with respect to the training strategy, it's very simple. In the first step, stage one, they train the adapter and image head, which is to say whatever turns the encoded text into the large language model format for both of these encoders here, as well as the image head, which is this head right here, the text detokenizer. And then in step two, they train everything except for the encoders. So that's stage two. If you look here, handles unified pre-training, all components except the understanding and generation decoders. And then finally, they use supervised fine-tuning. Where is it? It's somewhere here. Supervised fine-tuning in order to train the encoder. So this is the training pipeline according to the paper. And then they have a section called data scaling, which is too long. All it says is that there's more data and there's more synthetic data, because they observe that in the real world, the data lacks quality and contains noise. So to alleviate that, they have now a 1-to-1 ratio of synthetic to authentic data, if you wish. Okay, let me move this so we can read the rest. And when it comes to model size, you can see that they scaled this up pretty enormously from Pro 1B to 7B. So the most important things is they have double the amount of heads, and the embedding size, that is to say the model dimension. So what is the embedding dimension of every token in the model has also been doubled. Whereas the context window is the same, and they also add 6 blocks on the decoder as well. So it's only going up, and therefore this is why the paper isn't that impressive to me, because it seems like it's just simply scaled what they had before. But this is my opinion. They also have a bunch of hyperparameters here. One thing I thought was quite compelling is that they have a relatively low beta 2 value for atom W. It's usually around 0.999. So perhaps this is an image specific hyperparameter that is better for convergence. I'm not an expert in multimodal LLM, so I couldn't tell you. There's all of the valuation data here, which is available. They compare to all of the state of the art. And then we can just jump to the conclusion. There's also a few prompts here. I'd recommend you reading them if you want to pause right now and see what the LLM generated. And in the conclusion, they state that They improved their model by 3 ways, which is improving the training strategy, adding more data, and making the model bigger. So data and model, this is literally scaling. And then with respect to training strategy, I kind of skipped over it, but they do mention right here that there's more training emphasis in stage 1 and it's more focused in stage 2. So in the first training stage, they just have more data, and the second training stage, they remove ImageNet, which is used in the first data set in the first stage. So once again, it's kind of increasing the amount of data and segmenting it so that the model has a particular goal in each stage of training. And otherwise, my thoughts are that I understand why people are skeptic, especially on X, regarding Deepseek, because these papers are just coming out left and right, and they're pretty ambiguous. Like, they don't go into the details of what they're doing. So you can take their word for it, or you can be skeptical. It's up to you. I will note that they do state their limitations, which is that the model can only handle 384 by 384 inputs. And this just means that small regions, which in their example is like the face, are under detailed. But this is going to be improved by, they say it somewhere here, increasing the image resolution. So what a genius idea to increase the image resolution to improve the detail. But yeah, that's the paper. It's it's really high level. They do have other papers on the previous models, and there's more detail there. So I'll link Janus Flow, which is the one that I read as well. Otherwise, have a good day.